I am back. Okay, well, where have I been? Just been busy, Been busy with work, co op, everything. And school started again. I've been just like doing stuff that was more important. And initially, I thought I wouldn't make these videos because I'm super busy still right now. But at the end of the day, if I'm not the one making them, no one's going to make them. So, yeah, there they are. The videos are going to keep coming, I hope. If things get busy, I'm going to have to shut it down. Plus, if you guys aren't watching it, again, I'm gonna have to shut it down. But I know you guys will watch it, so we'll keep them going. I'll try to keep it every week or every 2 weeks. I'll help out with electronics too as well. I know how it can be sometimes. I also wanted to take the chance to talk about maybe a little bit about the future of this channel. Um, First off, I know y'all not locked in though. Oh man, like already, like the class just started and y'all already need help. I had a couple of buddies like just stop me on campus, be like, "Yo, we need the videos back." Like, gotta hustle season, people. Like, lock in, please. I locked in so hard, my hair grew back. Anyhow, that's besides the point. Let's talk about the future of this channel. I don't know if I just want to keep this um, recording videos for classes and then putting them out and having people watch them. I know it's super helpful, but I don't want to. I don't want that to be the bulk of my channel. I think I think it would be better for me, for myself, to just document my journey as a student. Um, going through my undergrad, the research that I've done, what I've learned with doing research, maybe present my own research here, and anything regarding with my honors project on my physics side as well, my capstone project, electrical engineering, all that good stuff. And it would be nice for me to look back on my journey and look at the things I've accomplished, how much I've grown as a person, and honestly, just being grateful for everything that I've went through to be the person that I wanted to be. And so that's going to be the future of this channel. So on top of just this lecture style videos, I'm also going to talk about my experience and document that journey, as well as give tips and tricks, because I've gotten feedback from a lot of people that they just don't watch the videos for the content that I provide. A lot of you guys really like my humor as well, and just me in general. So I'm going to post content, regarding that as well. Hopefully I have the time for it. And with that being said, a couple of words about electronics too. So there's a little bit of a mindset shift that you need to have going from electronics one to electronics two. So electronics one is an analysis based course. So you look at a circuit, you analyze it, you find a gain, and then blah 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 blah. You get an answer, and that's it. For electronics two, you need to look at the circuit differently. You need to look at the circuit more of a. You need to sense the circuit. If I had to put it right word, you need to sense it. You need to look at a circuit and kind of like take a deep breath and know exactly what's going on and how you can get the answer as quick as possible. Electronics one is more like a maze because you need to do a lot of KCL, KVLs, and everything. Electronics 2 is more like a puzzle. You need to recognize patterns. You need to be good at looking at a circuit and be like, oh, bingo, this is that, this is that. I can combine these two concepts together, boom, and then that helps me on another part of the circuit. So that's the type of mindset you need to develop for electronics 2. And oftentimes it's the people that still have an electronics 1 approach in their head that do not succeed as well as they would want to for electronics 2. So with that being said, let's get started here. So this is lecture 1. Feels good to be back. Well, today we're going to find R out. Now, what is R out? R out is the output impedance. Let's say you have some sort of circuit like this. Boom. It doesn't matter what. Like this. And then this is V0. This is plus minus. This is V out. This would be R out. All right. We all know this. If you don't know this, go watch my cookies and cram. At least that. Refresh your memory and come back to this one. Okay. So why do we need to care so much about R out? Because we want to find gain in the most efficient way possible, and electronics one method will not allow you to do so. And why do I say that? Is because electronics one, all your circuits only have one transistor. In electronics two, you might have so many transistors, and you can't replace each of the transistors by the AC small signal model and then do all KCLs and KVLs. If you're Albert Einstein, you're still gonna mess up, and you're a regular Joe, so you will screw up so bad that you'll get a -1 on your final exam. So what are we going to use to calculate gain here? So AV is equal minus GM R out. This GM, we're going to look at that in a future lecture, but just remember this is the transconductance of your circuit. R out is the output impedance of your circuit. I have a couple of rules when calculating R out. First of all, you need to disable all sources, both DC and AC. Replace all of the transistors with resistors. Now you might see this cheat sheet that I have right here. It looks very familiar. You guys probably seen it. So we're going to use that as a reference to find our outs. You need to get very, very familiar with this and know exactly where everything is. For now, this you don't need to worry about so much. We're only going to focus on these ones for now, okay? So replace all transistors with resistors, and then you're going to combine, boom, you find R out. So you guys know my style. I don't like to dwell on theory. I like to look at practical examples and develop our skills from there. So that's what we'll do. So finding only R out of the circuit below. So this is the circuit that we have. And then you can see we have M1 and M2 being our two MOSFETs. And the drain of M1 is connected to the source of M1 or the drain of M2 through RP resistance. Now we're just going to kind of like ignore the existence of that one for a minute and look at the broad circuit here. Now, when you look at this, first thing you want to do is disable all sources. So from here, this is going to go to ground. It's a DC source. This goes to ground. So we have ground, 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 boom, boom. This is what you got going on. And then from here, I just wanted to take a look at the circuit, like make as if you're an eagle looking down. All right. You see two transistors. The moment you see two transistors, you need to start thinking, okay, I'm going to work from the ground up. So over here, I'm going to start from the bottom and I'll work my way to the top like this. This step-by-step process makes it easier for you to change your transistors into resistors. So I'm going to work my way up and I'm going to reach this point, the drain. So here, I can replace M2 by RM2. What is RM2? The equivalent resistance of M2. So looking at here, we have the drain and we notice that the source and the gate is connected to ground. So that means I need to go to my cheat sheet. I need to find a MOSFET. That MOSFET, I'm looking at it from the drain. The gate and the source is connected to ground. Okay, so let's do that. And make sure you're looking at the right MOSFET because I've done that mistake so many times. This is a NMOS. You know, you don't want to look at a PMOS and completely screw up unless those values are the same sometimes, which can happen. So look at an NMOS. So here we have an NMOS. Okay. I'm looking at the drain. The gate is connected to ground, but the source is connected to RS. However, RS is a resistance. Here, we have no resistance. So in that case, it would just mean that we can use this equation and we can use this equivalent resistance, except this will be 0. So anything that I have in my equation here, which has RS, goes to 0 and goes to 0. That means I can use this equation, that's the resistor, that's going to replace this transistor right here. So I'll do that. So here we have RM2 is equal to 1 plus GM2RS, RO2 plus RS. However, we just said that this RS is 0, so this goes away, this goes away. So RM2 is just equal to RO2. Nice and simple. So now I'll take this, between this point and the ground, this transistor will be replaced by RM2, which is equal to RO2. And this is what we have here. This is our final circuit. Well, pre-final circuit. So we have this going on. Okay, this is the resistor that represents M2. So now we're going to do the same thing. So this one has been replaced. Now I'll walk my way up even. I notice a transistor, so I keep on going. Now this is the one I need to find. I need to find R out. I need to replace M1 by a resistor so I can find R out, because R out is going to be the combination of all of the resistances that you have looking at that point. Okay. Now you might notice that there's an RP going on here, and this is a little bit annoying. Usually when that happens and your professor, we all know the professor. One sec. Yeah, that professor, he loves putting like small resistors just to make your life harder. But we should not be scared by that. We should be ready for it. And how are we ready for it? We're smart. So what are we going to do? What I suggest for you to do is to draw the small signal model. Now, you don't want to do analysis with it, but you're just going to get an intuition, right? It's important to think intuitively about your circuits at this point. So I'm going to draw the small signal model, but I'm not going to do any analysis. So again, small signal model for M1. So we have the gate, the source, the drain. This is GM VGS. This is VGS. This is the RO1. This is the effect of channel modulation resistance associated with MOSFET number 1. You don't know what the hell I just said, you go back to my previous videos, electronics 1, you watch it, you come back, okay? Very important. Okay, so here I have my small signal model for MOSFET number 1. Now I need to look at RP. This RP here is connected at the drain and the source. So this is my drain, this is my source. I'm just going to connect my RP here. Oh, I noticed that this RP is parallel to RO1. So that means it's pretty much the same resistance, right? You have something in parallel, you can combine them together. When I say the same resistance, I just mean that it's one resistor. All right, I use my words wrong here. It's just one resistor. It's something parallel with something else, just one resistor. It's not multiple resistors. So I'm just going to say that this is RO1 parallel with RP, and I'm going to call that RO1 prime. So RO1 prime is equal to RO1 parallel with RP. So everything here goes away, and I have this here, RO1 prime. Now, imagine this is just RO1, and I have a prime to it. Okay, this is just RO1, but I have a prime. Okay, we just combine our RP inside of it. So now go back to the previous schematic, ignore RP since we already have it in terms of RO1 prime. So now you had that resistor RP that was annoying, but you already combined it with the RO1. So that means you can ignore it and consider RO1 prime only. You see what I did there? You had something that was annoying, you drew the small signal model, you realized it was parallel with RO, and you're like, okay, it's the same thing, like it's in parallel, so I can call it RO1 prime and then do my analysis from there. And I can ignore it. So this is what it was before. But then I keep in mind that this has RO1 prime inside, and I ignore that one. Okay? Remember, we have RO1 prime and not RO1. It's RO1 prime. Okay? Now, using the cheat sheet, we apply the same method. So I'm looking here at the drain, gate, and source. So gate is connected to ground, and source is connected to a resistor. So that's what I go to find. I'm looking at the drain, gate is connected to ground, and source is connected to a resistor. All right, so this is interesting. So now our RS here actually has a value. Our RS here will take the value of RO2. Nice and simple, you're just replacing things. Okay, now we have R out is equal to GM1 RS, RO1 prime, remember, plus RS. Here RS is RO2, so we have 1 plus GM1 RO2 times RO1 prime plus RO2. Okay, now what is RO1 prime? It is RO1 parallel with RP. So I do the replacement right here, and then this is my final equation for R out. Now in electronics too, we don't want big bulky equations because it gives us less information about the circuit for our intuition. Mathematically, it's very correct. Intuitively, you can't get a lot out of it. So what we're going to do an approximation, right? GMRO is much greater than 1. That's our approximation that we're going to use here. And you can use this approximation at any point during the course. And this approximation is valid. Check out my videos for electronics 1 if you want to know more about this. So this was my equation right here. Now GMRO is much greater than 1. That means in this part, I can ignore this one. So then what happens is just I have this equation because I ignored the 1. Now I notice that RO2 and RO2 is common. So I'm going to take RO2 out here. All right. And then this thing is just equal to RO1 prime, right? So that means, again, when I take RO2 common, I have a plus 1 right here. All right, because I factored it out. So again, GMRO1 prime is greater than 1, so I can ignore this one. So this is my final equation, GMRO1 parallel with RP times RO2. And this is my final approximated equation for R out. Now, hope you had fun with this video. Next video, we're going to look at GM, and we're going to calculate our first gain using GMR out. All right, until then, take care, share Max. All right, share this video, Max. Thank you.